Here we previously had our LED circuit plugged directly into 5 volts. This allows the LED to always be on. However, if you want the Arduino to control it, you're going to need to use a digital pin. All the pins on this side are digital pins. We're going to plug this in to digital pin 13. The Arduino program is currently telling digital pin 13 to be high and low. This will cause our LED to blink. You can change how quickly the LED blinks using the Arduino code.
We're going to start with one of the simplest Arduino codes, which is the blink program. Go to File, Examples, Basics, Blink. The example code will show up. We're going to write our own code, but this way we have a reference. Notice over here, it already tells you what the code is going to do. It's going to turn on an LED for 1 second and then turn it off for 1 second. Let's start our code by writing a comment at the top. This code is for blink. The LED will be on pin 13. Notice that right now there are orange and black text in the code. That means that the computer thinks this is a real part of the code. So what we need to do is preface it with 2 backslashes. This grays out all of these comments so that the computer will ignore it when it's running the code. The first part of the code is the void setup. Anything within this part will be done one time. This is where you want to make your pin an output. This way, the Arduino will know that the digital pin 13 is an output and will send a current out through that pin. Please note that the code is case sensitive. So for example, if you wrote pin mode incorrectly, it would not turn orange. By turning the correct color, you know that you have written the code with the correct syntax. The next part of the code is the void loop. Anything that you write in here will be run over and over and over again. What we're going to do is have the pin 13 write high when you want the LED to be on and low when you want the LED to be off. By placing a delay between the high and the low, you're letting it know how long you want it to be on or off. 1,000 milliseconds is the equivalent of 1 second. So unlike the example code, we're going to delay for half a second when we want it to be off. Notice that I wrote 13 instead of LED. That's because this is the part of the code that lets you know what pin the command is going to be for. However, to simplify things, at the very top, you can write int LED equals 13. This lets the computer know that the word LED now represents the number 13. Anywhere from this point on, when the computer sees the number 13, it will also mean the same thing as LED. So you can replace those numbers with the word LED. You might wonder, why do we do this? Because as your code gets more complicated, you may have dozens and dozens of commands with that pin number in it. Now, all I have to do if I want to change the pin is go to this very first line and change it to, for example, 8. Now the LED will be on pin 8 instead of pin 13 for the entire rest of the code. Before you upload the code, let's verify to make sure we didn't make any mistakes. I put several mistakes in this code on purpose so you can learn how to troubleshoot. Click the check mark, and the code will be highlighted where there is a mistake. Notice for void setup, I put an open parentheses, but I didn't close the parentheses. The computer is very particular about this, so the code has to be written exactly correctly. This is one of the most common mistakes. If you forget to put a semicolon at the end of your row, the code will not be completely read. So you need to put a semicolon always at the end of a row. Here I made a mistake on the inside of the parentheses. Instead of using a semicolon, we have to use a comma there. And finally, if you compare to the code over here, you notice that hi has to be in all caps. So it is definitely case sensitive, and when you do it correctly, the command changes color. Same thing here with digital write. And finally, you need a curly brace at the very end to close the loop. One nice feature is if you put your cursor right next to the curly brace, it'll show where the other side of the curly brace is. So this block is now complete. Similarly here, you can see this block is also closed. Once you verify and everything in the code is correct, there will be no error messages. At this point, you can upload to the board. Double check that your board is the correct one because there are many different types of Arduino. Also make sure that the serial port is connected. If this is grayed out, you are not actually connected to the board. Upload the code, and sometimes you get this error message. It just means that you're not using the correct COM. Instead, just select the correct COM. And now your code should be running.